All right, class. First of all, this is a redoing of lecture for January 6th, 2021, because my technology did not work correctly. So we're going to go for it. This is 4.2, and we are talking about amplitude, period, and reflection. Actually, the other way around here. So let's go with, let me spell it out for you here first here. So amplitude, we're going to learn what in the world that is. Reflection, I think you should probably know what that means as far as graphs are concerned. And we're also going to take a look at period. All right. So this is kind of like the first part of a two-part series. 4.2 is beginning with like the basic graphs. And then at 4.3, we're going to get a little bit more advanced with this stuff. So first things first, let's go back, rewind in our mind. Let's go back. And we're going to go back to 4.1. So what do we learn about from 4.1? A few things here. Actually, no, I should tell you this. um, let's see. 4.1 was just an introduction to all these graphs. In fact, the introduction to all the 6 trig functions here. Then 4.2 and 4.3, we're going to go just work with the sine function and the cosine function. Now we're going to get a little bit more in depth. 4.2 is kind of like the basic pieces. 4.3 completes it, I guess, or finishes, I guess it would be better. Finishes the graphing aspect of it. And then what we do is 4.4, we go back and say, hey, hold on, we've been working on these 2 trig functions here, and let's go back and do the exact same stuff with the other 4 trig functions and catch those guys up. That's kind of what we're doing there. All right, just to kind of give you a the forward look into chapter 4. So there it is. So 4.2, 4.3, we're looking at the sine and cosine curves, getting really, really good in graphing them. That's what we want to do. Really good in graphing them. All right, so let's go back. Go back to 4.1. What in the world did we learn in 4.1? So first things first, we learned this. We learned that we have something called the sine curve. Sine curve is we take this away from the unit circle. Now we're going to make a curve based upon the sine ratios at a given point. So let's do this here. So first things first, usually with a graph, we go out to 2 pi. And there are 4 critical points that we normally look at, actually 5 critical points we normally look at. We take half of that, so half of 2 pi is pi, half of that would be pi over 2. And then we start sort of counting. This is 1 pi over 2, this is technically 2 pi over 2, so this has to be 3 pi over 2. And the sine curve has, let me erase that now because we don't need it. All right, so we have important points here. 0, 0 is an important point for sine. I do want to erase that here. Hold on. Why is not erasing? Eraser. Erase the little 1. There you go. And then back to pen. Okay. So the other important point is pi over 2 comma 1. Then it's pi 0. Then it's 3 pi over 2 comma negative 1. And then it's 2 pi. Those are called critical points. Those are the ones we normally try to manipulate in order to do the sine curve. And so the sine curve goes like this, goes up, starts off at 0, 0, goes up, goes down, and then comes right back up. Now, we also know it does keep on going, right? It does keep on going this direction, it does keep on going this direction. So this is what we know about the sine curve. We also know that sine curve is a odd function. And so we know this small little interesting idea about the sine curve is that if the angle value is negative inside here, what we can do, because it's an odd function, if we want to change that theta to positive, we do have to put a negative outside in front of the sine curve. Okay, there's my sine curve stuff. All right, moving on. So I'm actually just put like this. Here it is, sine. Okay. Let me erase this little piece here since I don't need it anymore. Okay, then we learned something about the cosine curve. All right, the cosine curve. What's happening here is it's a little bit different. Still is a curve. And so let's go up to 1, up to down to -1. This is 0. So again, 2 pi is going to be here. Half of that would be pi. Half of that would be pi over 2. So again, this is pi over 2, 2 pi over 2, 3 pi over 2, and this has to be 4 pi over 2. Perfect. Okay, the cosine curve. What are the critical points for the cosine curve? Is 0, 1, pi over 2, 0, pi -1, 3 pi over 2, 0, and 2 pi. So there it is. It goes like this. And the cosine curve is called a valley because it just kind of goes down. You think of a valley there, you think about it. All right, so then the cosine curve, kind of interesting. We covered this last time here. Cosine curve is an even function. So if I take a negative theta here, to compensate, it's an even function, so therefore it's symmetric along the y-axis. Therefore, I can take out a negative or a positive out of this, and it's going to still give me the same exact value. So no problem there. Okay, those two things. Based upon those two things, we're going to do the rest of the stuff. So let's jam. So this is called transformations. So first things first is the amplitude. Our amplitude is technically is how much it goes from the middle to the end. So the formula for amplitude first looks like this. A is equal to 1/2, and it's the maximum height minus the minimum height. Absolute value here. So let's talk about amplitude. So the normal, let's talk about sine. Maybe sine would be the easiest example to start off with here. So the normal function for sine, again, I'm kind of drawing this out real quickly here. It bounces between 1 and -1. So the amplitude is really just this. It's from the middle section. It's how far it goes up. It goes 1 unit up. That's the, now, can you measure it going down? Absolutely, because it's going to be the exact same thing. So if we change this, that means this little piece is going to change with us as well. So let's do this here. I'm going to have you graph this. So exercise 1. Graph y is equal to 3 sine of x. Okay, so if you don't have graph paper, no problem. You can make graph paper out of what you're writing with, or the graph paper that's here. And so let's go for it. This is a sine curve. So what's the few things we should know? So in your mind, as soon as I say graph sine, in your mind, you should automatically think of these points really quick here. Sorry, I should actually make this. Let me redo that real quickly here. Boom. Okay. We should automatically think of that point, that point, that point, that point, and that point. So the regular sine curve goes like this. And so what we've done is we've changed the amplitude. There's that little number, instead of being a 1, now it's a 3. So what happens here? Again, it's from the middle, right? Instead of going up to 1, now our maximum value is going to be 3 somewhere along this line. So notice our dots along the x-axis have not changed. So graph this out if you need to here. They will change into 4.3, but not yet. So 0, 0 is still the 0 marker. pi 0 is still along the x-axis, and 2 pi. Now pi over 2, instead of going up to 1, now it's going to go up to 3. That's what's happening here. And instead of going down to -1, now it's going to go down to -3. So there's what we have here. So graphing this up, down, and back up. And make sure you don't make this into, don't make it a V shape. Don't make any corners here. You don't want that. You want a smooth curve. You want to gently curve up and then start gently curving down. All right. So what we kind of normally do with sine and cosine is we start graphing them in stages. And so if we're to graph them initially, we'd graph them. Let me just back up just a little bit here. So what we do normally like this is we would say, oh, let me do it in probably a black color. Let me do this here. We say, look, the original graph would be like this. Here, 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 and here. That would be the original function. What we did is we went up to, and from 0, 0, went up to the 3 value instead of the 1 value, still going through 0. We went down to the -3 value and came up to 0. And that's the way we do it. We normally draw points from the original graph and we change them up to graph this. Okay, we know it keeps on going, right? But we normally, if there's nothing to tell you how much you're to graph, or there's no domain restriction, we normally do 1 period. On the homework, sometimes they'll actually say, draw 2 periods of the sine curve. So we'll get to that in just a bit here. Okay, so that's how we see it progressing here. Let's do this here. Let's do example number 2. And we'll do it the regular way. We normally do this here. So exercise number 2, graph for me y is equal to 1/2 cosine x. So again, in your mind, as soon as I say cosine x, and I can start putting this one right here in the homework. It does say graph 1 complete revolution. Okay, so off to the side inside your brain, really quick here, I have that dot goes down, comes back up, and back up to the top. That's my cosine curve. That's the way I think about it. That's the way it's memorized. That's the way you're going to have it memorized. All right, so the cosine curve originally, let's put dots in, and then we'll fill in the last dot that we have. So cosine curve originally starts off at 0, 1, goes through 0 at pi over 2, goes to -1 at pi, goes up to 0 at 3 pi over 2, and back up to 1 at 2 pi. Okay, except that's not the graph we're going to have to graph entirely. So we are graphing 1/2. So we are going up only to that much right there. So now let's fill in the dots that we need in order to graph our function here. So the dot that I'm going to be graphing for is now 0, 1/2. Still pi over 2, 0. I still got that one. So at pi, we're going down to -1/2 now. And then we're at 0 at 3 pi over 2. And we're going up to only 1/2 on at 2 pi. Okay, let's graph it. I think we're ready, set, go. So it starts off high. There's my cosine curve. Very flat, isn't it? Very flat. Goes like this, comes back up, and back to here. Maybe that went a little bit too fast here. How about that's better like that. Boom, there it is. 1 complete revolution of my cosine curve of 1/2 cosine x. Perfecto. Okay, so let's get a little bit more complicated. And I'm kind of just bouncing between sine and cosine curve. That's what I'm doing here. So can you graph for me? Y is equal to -3 sine of x. So one complete revolution. All right, that little negative there, what's in the world it's doing? So amplitude, the number here, that's my amplitude. But then you have this little negative on the outside. All right, so the negative on the outside means it is a reflection about the x-axis. So let's start graphing our dots and let's start putting it together. So again, sine curve in my mind, real quick here. Sine curve is 0, 0, up to the 1, down to 0, -1, back up to 0. So let's go for it here. So original dots would be, if I'm just graphing sine of x, sine of x would be original dot, original dot, original dot, another original dot, and last original dot. There it is. That's my sine of x. If I'm going to reflect this about the x-axis, let me do dark red here. If this is reflected about the x-axis, still I get my 0, 0 dot, but instead of going up, now I'm going down to -3. Still at 0, 0, going up to, oh sorry, not, it's +1 so far. I haven't done the stretching yet, and back down to 0. Oh, we're good. So my first graph was sine of x. My second graph is negative sine of x. That's what I just did just now. And let's see, purple. Let's go with purple. And then finally, I'm going to add in my 3 value in here. So there's all these little red dots are going to get stretched along the y-axis by 3. Notice the ones that are actually on the 0 marker, they don't move. They don't get stretched because they're right at the center. So there it is. My -3 sine x curve goes like this. It's going to go down, touch, come back up, and down. And it's an upside down sine curve. That's it. Upside down sine curve with amplitude 3. Okay, if you feel comfortable with that, that's perfect. I do want to do this here. Let me jump to a graphing software that's online, which I think is a pretty cool thing. This is Desmos. If you guys have never heard of Desmos, DESMOS.com. It's a pretty cool graphing software. It can pretty much graph a lot of things, at least let's say that. So I do have my sine curve. Everybody agreed? This is my sine curve setup right here. As we finish up at 4.3, we will get this complicated right here. It'll be an A for amplitude right here. Sine of B multiplying x minus c, and plus d at the end. All right, let's go with it here. So here's my sliders. Let's see if this makes sense so far. So this is my A slider. This is the one that gets me to change values here. So just want to know, here's my regular kind of sine curve, right? And so if I go like this, notice that's exactly what we did in our first graph that we did. We actually went up all the way up to 3 right here. It looks something like that. All right, and as you decrease it, obviously it goes down to, here's my 1, right? But then if I go down less than 1, then I get something that looks like this. Here's my 1/2. And then I go down all the way to 0.1. That's cool. Okay. And then I can just do this. I can put in a negative. I can negate this guy and put a little negative right there. And let's just see what happens to this curve if I do that. There it is. It's just the switch right here. It just went down. In fact, maybe even better to show it like this. Let me adjust this slide here to a -1. There it is. So let's do this here. There's my expansion up. There's my expansion down. Going below 1. There it is. And if I keep on going to negative territory, notice what happens. It just kind of flips on you. So now we're at -1 right there. So that little slider kind of shows you that little piece. And back up to the original sine curve. Okay. So the other part we're going to deal with is the b value right here. So b is whatever's multiplying x. So the b is the multiplier to x. So let's see what happens here as I adjust this up to a 5. So this one, and let's go with it here. So I'm getting bigger and bigger. Oh, look at that. We can either say the graph gets squished horizontally. So the bigger the number, actually, the faster it goes. Faster it goes up and down. So bring it back to the original 1 value. There it is. And if I bring it down this way, notice it just gets flattened out right here. So again, the bigger the number, we call this a horizontal compression, which means the horizontal line gets sort of compressed upon itself. So we're going to deal with this right now. 4.3, we're going to deal with the C and the D values. But for now, we're just dealing with this right here. So let me go back to the original one. Boom. We'll talk about this when we get to 4.3 as well. But let's jump to this one here. And let's go with it here. Let's see. How do we graph this next one here? Well, this next one is called a period change. A period change means, let's define it first here. And so, period nope, sorry, okay, let's go with it here. I can just put this here. Graph starts repeating itself. So we already know these because we know trig functions here. We know that sine and cosine starts repeating itself once it passes 360 degrees, or 2 pi. So what we do is we designate this little piece to be the value here. Let me find something really quick here. That's the way to do it. Okay, so there's kind of 2 different ways to think about it. And let me just do the setup here. So this is example. Oh, I got to find out what example this is. I think it's 4. Yep, it's 4. Example 4. Can you graph for me y is equal to cosine 2x? That's what I want. I want to graph the cosine of 2x. All right, let's see. Oh yeah, let's do it. We'll do this one way. We'll do number 5 another way. And then we're going to see which way you like best. Okay, so first way is we understand already that sine and cosine has a period of 2 pi. So what we do is we take 2 pi and we divide it by the number that's right here. We'll formalize it in just a bit here. So we just take that number and we say, oh, voila, it's pi. So here's what we need to do. Cosine starts off at high number, hits 0, goes down to negative, goes up to 0, goes up to the high number again. This we have to do now, instead of in 2 pi, we got to do it in pi. So from here to here, it has to be a pi. So we erase this stuff here. And we say to ourselves, okay, this is the only change for cosine. Cosine's only change is the fact that now we have to do everything in terms of pi. So looks like for cosine, I start off at 1, 0. And then what's going to happen is it's going to have to go down and come back up when it hits pi, because that's what this means. Okay, so then I know cosine, I know what that means. In the middle point is the one that's actually always in below, right there. And then half of this piece is always that hits the 0 marker. So these little lines are here, but that means it hits the 0 marker right there. And then it hits the 0 marker right there on the second side. So there's my little 2 0 markers right there. And done. Here it is. So I'm going to graph cosine. Oh, a little bit too high there. Graph cosine going like this. Comes back up, curves a little bit here. And boom, there's cosine. Note, I do want you to see something here, though. I do want you to see something as we keep on going. If we keep on going with this. Dink, dink, dink. So notice what we have here. So what does this little 2 mean? That's exactly what it means. It means that we're going to have 2 cycles. Here's one cycle. Here's another cycle within the value from 0 to 2 pi, right? From here to here, we have ourselves these 2 cycles. That's what that 2 represents. That's why it goes twice as fast. Okay, so that's one way of graphing it. Let's switch to cosine. Oh, sorry, let's switch to sine. And let's do the other way. This is the textbook method of doing it. Y is equal to sine 2x. How about that? Well, that's all we'll do. Okay, so textbook method. You guys ready? So instead of taking the 2 pi, dividing it by 2, the textbook method says this. It says, hey, look, originally, the x value has to be between 0 and 2 pi. That's the original piece. What we have in our hands is a 2x in here. So what's really happening is I'm doing all of this in terms of 2x this time. So here's my start, right? And here's my end of my period. Okay, so what I do, so notice that this is my start, right? My start starts here, and my finish usually happens here, and usually has an x inside it. But this piece, what I'm going to do now is I'm going to put in a 2x in here. I'm still going to try to solve for x. So all I got to do, divide by 2 everywhere, and this gets me exactly this. So my period is going to be from 0 to pi. And again, it's kind of saying the same thing. It's just a matter of which way you want to look at it. So I go starting off high, going down to 0, going down to a negative, coming back up. All this has to happen from 0 to pi. Okay, so pi is the end result. So that means it has to be a high over here. We start off high, the middle section here. So notice we're kind of doing the exact same thing, just for a slightly different reason. And so in this case, there it is. So graphing, boom, 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 putting back up, voila, we got ourselves that one. That was one complete cycle. Can we do it again? Absolutely, if you want to. Do it again. You don't have to. In the textbook, sometimes it does say graph for me one complete revolution. Sometimes on the homework, it says graph for me 2 revolutions. So you got to be just careful on what the instructions tell you to do. But you know what? I think we're ready. I think we're ready for the rest of this here. So that's example 5. Let me make that 5 just a little bit better. Boom. Okay, so real quick here, 4 or 5. Which one did you like? Did you like this one? Just taking the 2 pi and dividing the number out and just setting that up? Or did you like example 5, where you take an inequality measurement and you get it back down to an X value in the middle, and then you know exactly where your start position is, you know exactly where your end position is, you're just done. Okay, well, that's up to you. You decide however you want. Okay, which way do I like? I kind of prefer the first method. I prefer the first method usually. Unless it gets really, really complicated, I'll do the second measure because I think it would just a little tiny bit more work for me if you go the second way around. Okay, so let's start putting things together here. I think we're cooling that already here. So y is equal to 4 cosine 1/2 x. Oof. Okay, show you some tricks of the trade here as well. So let's see, and we got ourselves this one, and then we've got 3 more graphs to go. And we'll be done. So let's go with it. 4 cosine 1/2 x. So first things first. In our mind, we're graphing cosine. So in my mind, I have myself this graph here, these important critical points right here, and that's what I'm thinking about. That's my cosine curve. If I want to graph it, I can graph it, right? So my original dot in purple is 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi. There's my original one. Okay, what am I doing next? Next is the 4. So now instead of it being, so this original one was just this right here. Let me switch color. So now what I'm going to do, I'm going to do 4 cosine x. No problem. So all the ones get transferred up to 4. All the negative ones get transferred down to negative 4. And all my zeros stay as zeros. There it is. They didn't change whatsoever. Okay, and my last graph, that's going to be my 4 cosine 1/2 x. So doing the first way of doing this, you're going to go what? 2 pi over 1/2. Right, that's the 2 pi. That's how normally the cosine curve goes in a period. And then we're dividing by this number right here. Okay, the only thing is with this one, in order to cancel off the denominators, you actually multiply by 2, both top and bottom, and you get yourself 4 pi. Ooh, there it is. So now it's 4 pi. So we got ourselves a little problem. So my graph sheet of paper only goes out to 2 pi, or it could be that you're graphing this on your notebook, and your notebook is finishing up. So there's no more space to make actually another graph, and so large. So what you can do is you can adjust your scale. We good? So here's what I'm going to teach you. Ready? So I'm going to say this piece right here is 4 pi. This guy is 2 pi. This one is pi. So that's pi, 2 pi. So that means this has to be 3 pi. Are we good? And notice I can still connect my red dots together. Okay, you can do that, absolutely. And that'd be no problem because what you're doing is you're just changing the scale, but you have to be careful that you show me what the scale is, okay? Perfectly fine to do that. In this case, that's what I would do because I'm running out of space. So I'm showing the scale. If you did have enough to sort of redraw the graph and make it all way, way wider, that's fine too. But I'm going to go back, or I'm going to just graph my cosine curve now. So there it is. You can rescale, no problem in rescaling. There it is, one full graph. Cosine. It feels like cheating. It feels like cheating a little bit, doesn't it? Like, hey, I just rescaled it. But you rescaled it knowing what you were doing so that it fits the graph just fine. That is absolutely fine. Okay, let's jump into something here. A little bit more. How about this? Example number 7, a little bit more complicated. Graph for me. Y is equal to negative 3 sine of a negative 2x. Now this goes back to what we did in the beginning. Remember how we said that sine is a odd function, or is an odd function, I should say. Because sine is an odd function, sine negative theta is the same thing as negative sine positive theta. So we do not ever work with our b value being a negative. We don't do that, never do, never will. So what we do is we move that negative value out as a multiplier for sine and tangent, or we just make it disappear if it's cosine because it's an even function. So in this case, we got ourselves graphing this now, negative of a negative 3 sine of 2x. And so if we do that, then technically we are just graphing this right here. So all yours, give yourself 30 seconds, or I'm going to give you 30 seconds. Can you graph that guy before I do? So 3 sine 2x. All right, I'm going to start here. So again, think about myself, think about sine. 0, 0 goes up, comes back down, and gets back up to 0. That's what I'm looking for. All right, I'm going to go over here. So I'm going to go 2 pi divided by this number over here. So I'm going to do everything I do from 0 to pi. Everything should happen. And it's also going to go all the way up to 3. So notice I'm actually changing things already. 3 here, negative 3 here. So by doing that little small thing on the side, on the left-hand side, I think I'm ready to actually put in my values for sine right away. So 0, 0. Let's see. So then the middle between here and here is going to be right here. Here's the middle between 0 and pi over 2. That piece, 1, 2, that's going to be up 3. There's my middle. At pi over 2, it's going to hit 0. And in the middle between pi over 2 and pi, it's going to hit negative 3. And it's going to go up to 0 by the time we hit pi. Done. I am done. There it is. It's a graph that now goes like this, comes back, and goes here. So it depends. If it said graph for me 2 complete revolutions, then we would do another one. If it says graph 1 complete revolution, then that's what you do here. All right, if it was cosine, then what we do, let's go back over here, just real quick here. If this was cosine, because cosine is an even function, this negative, it just drops out. And so in this case, if you were to do that, then it just turned into that, and you're graphing that. So that little negative stayed on the outside, did not get multiplied by another negative. Okay, two more. Let's go with 2 more. Actually, no, 1 more, because we have time for 1 more here. Example 8. Okay, graph for me. Oh, and then this one's going to be a fun one, change of scale. So here it is, y is equal to 2 cosine pi x. Ooh, this where everything gets fun. Everything now just got fun. And this is why we use radian measurement. That's why radians are actually real numbers. And here's where the trick of it all. So first things first, I have myself a cosine curve, right? So that means I start off high, I hit 0, I go down low, I go back up to 0, I go back up to my high number. That's my curve template for cosine. Next, here it is. I'm going to take my 2 pi, which is the period cosine normally is. I'm going to divide this by pi, the number that's multiplying x. These guys are gone, and my period now is 2. Okay, what is 2? 2 could be anything. So 2 could be 2 seconds. It takes cosine all the way down and comes all the way up in 2 seconds. It could be 2 milliseconds. It could be 2 days. It could be 2 hours. So this is where we say that cosine and sine, they model any behavior that goes up and down, and oscillates. So that's cool. So my scale here is wrong. My scale should be, and you can make the scale faster if you're slower if you choose it here. So I'm going to erase all these guys here. They don't need to be here. So I'm going to designate this to be a 2. This is 1. This is 1/2. And this is 1.5. It goes all the way up to 2, right? So I think I'm done. So I'm going to start off at 0, 2, my first dot. It hits 0 at 1/2. It hits -2 at 1. It hits 0 again at 1 and 1/2. And hits 2 at 2. So there it is. There's my cosine curve coming down, hitting the 0, coming back up, and voila. All right, I'll let you guys practice that on the homework. Then we're going to get together for 4.3, and then we'll do really some fun stuff. 4.3. Well, I wish you well, and see you in class.